Hey guys, thanks for tuning in. Today we're going to unbox something a little bit different than our usual Cartesian printer. This is the Cetus MK3. Alright, so we've got the printer, we've also got 3 spools of Cetus's branded PLA, and 3 nozzles. So we've got a 0.2, 0.4, and 0.6 millimeter spare nozzles here. These nozzles are a little bit interesting. I'll go over those in a second. So I guess formally this is called the 3DP-18-4A, or otherwise just the Cetus MK3. And I did say it's a little bit different than our standard Cartesian, and I mean that in the sense that it's still Cartesian, but you just have one upright, and the X arm just kind of cantilevers off of that. Kind of like that. So off camera, I'm going to take a couple minutes and browse through this, and then we'll start unboxing all the parts. So I've had just a couple minutes to browse through the manual. Primarily I was interested in the installation instructions, and it's quite a nice manual. Like, it's got some nice close-up color photos, outlining the key points of the installation. And then it has quite a few pages that goes over the on-screen menus as well as all of the software components on the back end. I'm not too concerned with that right now. I just want to get the thing built. So let's unbox all the parts. Power cord, obviously. So there's a small roll of PLA, and I really am not a fan of these tiny sample size rolls. They tend to be cumbersome to mount on a spool holder and feed them in and make sure they don't unwind and such. So we've got nozzles and Allen keys, some angle brackets, USB cable, this little 3D printed bracket of sorts, angled bracket thing, some PTFE tubing, and then some 2020s and some other smaller 2020s. We've got the power supply, which is interesting. It's kind of like a laptop style power supply. So we've got the bed. Oh, they give you some flush cutters, scraper. So this would be the hot end assembly. They've got a nice sock on there, it's even branded. And the sock actually wraps right around the nozzle tip as well, which is kind of interesting. So the nozzle itself is insulated as well, which is kind of required because of how the nozzle is designed in comparison to something like a E3D or an MK8. I'm using a little pancake stepper. And it looks like they're using a ribbon cable to power all this. All right. So this is kind of that cantilevering. So this would be the Z like this. And you'll notice that there's linear rails on both the Z and the X. It's pretty heavy. And this will be the rest of the base. Obviously that's the control box. And again, we have a linear rail on Y. So everything is linear rails. We have no V-slot wheels or anything like that here. And that's the end of that. So I've cut the zip ties that were holding all of these wires nicely bundled in little coils at the back here. The longest being the one that's going to reach the hot end. It's this ribbon type connector, so that's pretty obvious. But what we're looking for is the Z motor cable. They've nicely actually color coded this. So the Z motor on this assembly here is this guy, and it's yellow, and this one is yellow here. So that is going to go into there. So on the Z axis here, there are 3 screws loosely screwed in here, and those correspond to 3 holes on this upright bracket. So we're going to use these screws to attach this to here. Make sure that you're not pinching any of these wires between this upright piece and this piece here. So to do that, I'm going to need some of these Allen keys, I guess. quite a few little parts in this bag. Oh, that's kind of nice. They give you a little wrench for the hot end, the nozzle, I mean. Well, what we're looking for is this one. So I actually don't need the Allen key out of that parts bag because these are Phillips head screws. I just immediately assumed they would have been hex head. So remove the screws from the upright. I'm following the instructions verbatim. It would have probably made more sense to attach this first before attaching the cable to the motor. Though getting your fingers in there to attach the cable afterwards would also be pretty difficult. It's pretty close quarters. Okay. So as I said, you got to take some care to make sure you're not crushing any cables underneath there. All right, so I've got that connected. It's good and sturdy, that's for sure. So the next step, it says we need to take this red cable and plug it into the Y motor. The Y motor is already connected. So what they actually mean is the X motor, and we know that for sure because they've color-coded it like the other one. So it does say to route it through this little plastic bracket here. And then connect it just like that, I guess. Right now the Z is basically all the way at the top, so we know that that's as much slack as it's going to need, and then as it comes down it will just kind of fold over on itself. So now they say to connect the YZ end stop cable, well that's got to be this guy, it's the only one we have left, and it's going to connect to this little connector at the bottom of the printed bracket here. There we go. So the next step is we're going to route this ribbon cable here. You need to slide it underneath the Z motor, and then it says to run it up here and use this cable belt to kind of cinch it. There we go. And it doesn't need to be tight or anything, you're just doing that to stop it from kind of folding over on itself. So now we're ready to attach the hot end to the X carriage here. So there's just these two hex bolts, and they're going to bolt through these two holes in this metal back plate. Looking at this a little more closely, it's interesting how far out both the thermistor and the heater cartridge stick. I'm going to assume they're pushed in the correct amount, so they just may be longer heater cartridges than we're used to. And there seems to be some sort of a paste, maybe it's boron nitride or some sort of high temp thermal paste to help with that heat conductivity. So as I said, two hex bolts, and just bolt through these two back holes in this bracket. You may need to manually lift up the Z. It will sag on its own over time, but otherwise you won't have the clearance necessary to bolt this on. All right, almost looks like a printer now. So we can connect the ribbon cable. It is keyed, it only goes in one way. Let's route it like this. So when I connected the X motor cable, I forgot to tuck this into this little printed bracket here. So you should be able to kind of, there you go, nestle the cables in there like that. They're not going to slide out on their own. That's fine. So the next step is to assemble the spool holder, which is made up of these 2020 pieces, but we haven't put the bed on the printer and there is no mention of installing the bed. This is the bed. It has these recessed holes for the bolts. They're pan head bolts, or these tapered bolts, sorry. So if we raise up the Z again and move the Y forward here, the screws are already in here. There are 3 of them. The 4th here is completely recessed into this bottom bracket, so I don't think that's to be removed. So we'll just use these 3. And the bed's going to sit like this. So just rotate it until you can see that they line up. It is interesting that, that there is actually a fourth hole in the bed, but a different screw in that fourth hole. That feels really wrong to leave this fourth hole here with nothing kind of filling the recess, but it is what it is. That other bolt is completely flush under there. So now we can move on to the spool holder. As I kind of mentioned, we've got the 2020s. We also have the caps to kind of finish off the ends of those. And then we have these little angle brackets. So if you're not familiar with these, they slide in like that, and then you put a screw in there and that kind of pinches it between the back, the inside of the 2020 there, and puts pressure outwards. And then the other side would obviously slide into something like that for a 90-degree corner. So the spool holder generally gets assembled like this. Put this tall piece there, put one of these pegs facing that direction, and then the other one facing the same direction. Not sure if this goes on top. Nope, it goes like this. And so then your spool will sit on top of here. So I'm going to insert these angled brackets. That. And I should be able to just slide this one right down on top. That. And then just so they don't fall over, I'm going to bolt those on. So we have these little grub screws or set screws. You can almost think of it as an Allen bolt without a head. And that's what we're going to use to put that pressure that I mentioned. So I've got the main upright connected and it's super rigid. Not that it really needs to be all that rigid, it's just a spool holder. But it just goes to show you that these brackets do work quite well. So this bottom one, obviously I can't connect it like that. That doesn't make any sense, but I can connect it like this. And so on this upright here, I did connect two corner brackets, one on either side, but on this one, as well as this other small one, I'm just going to use one. That's all they give you, is enough to use one on those, but it makes sense that that's where you would kind of skimp, because there's really not a whole lot of force, not the amount of force that would be placed on this taller one. Interesting. So you'll notice also that there's a little notch out of here. So that allows this to slide in the end like that. That notch only exists on one side of the bracket, so I just tried to install it like this, and that won't go. So it would need to be, third time's a charm, it would need to be this way. We could also put it on the underside if we wanted to hide it a little bit more. There we go. So I immediately regretted all of that I said about using two brackets on the upright. While it is true that the upright would experience more forces than the rest of them, we only have enough brackets to do what we need to do. The last bracket needs to go something like this to stop the spool from just sliding off the end. So I'm gonna have to pull one of these two brackets out. So now this bracket is just going to go like that. And I guess we really don't need the grub screw in this top hole since it's not doing anything anymore. So we have an extra. So if you slide this bracket in enough, then you can put one of these caps over the end to give it a little bit more of a finished look. It should just snap right in there. There we go. And then same with the other ends. So there were enough of these plastic caps to cover all of the ends of the extrusions here. What I noticed is as I got to this last one, this one hole is tapped. I didn't notice any of the others being tapped. Like if I pop this off, it's just a smooth hole. I'm not quite sure why that's tapped. It makes no mention of that at all. I thought maybe this is supposed to bolt onto here somewhere, but for now, I'll just stick a plug in it. So we're left with some spare parts, which is kind of always the case. But in this bag, remember earlier on, I mentioned this like curved little bracket of sorts. I'm not even sure where this goes. There's no mention of this in the parts list in the manual, and nothing in the installation instructions about it. So I'm going to take the 2 bolts and that and throw it back in this bag. Maybe as I spend some time with the printer, I'll learn where this is supposed to go. For now, it's a bit of a mystery. I didn't mention it, but we also have one of these little needles for helping clear a clogged nozzle. I don't really use those myself. And in the box with the printer, there were 2 spare nozzles, one installed, so there's a 0.4 installed, and they give you both a 0.2 and a 0.6, so you can go a little bit larger as well. So these nozzles, there. As I mentioned, there's more of the nozzle tip exposed to, say, the airflow than in another nozzle style. So they have these nice silicone boots that go right over the tip, which is kind of cool. And so directly attached to the nozzle is this like heat break component. It's tapered to help steer the filament in. 1.75 millimeter filament is most of our printers, but that's kind of a unique design that it's all in one. So according to the installation instructions, that's all we need. We would probably want to be able to steer the filament into the hot end. So the filament is going to be, say, over here, probably overhand, and we want it to go in here. So that nicely fits that. There is also a spot on the back here where this can go, like this. So it just slides into here. And then if we had the spool kind of behind, we could do it underhand and up and through. This is really just to guide the filament. I mean, if you had some sort of a setup where you had this on a shelf up here, you could very easily just let it go down to the top, which is how I run most of my direct drive printers. So I think I'm ready to go away for a little while, get my hands dirty with this guy, and then we'll come back and we'll review the software aspects of it, as well as my initial first impressions. Looking at the printer, you know, it's clearly like a minimalist design. You'll notice there's no screen. I mean, there's no menus to go through or control knobs. Everything is tethered to your computer. So we're going to have a very different experience from a software side than we might be used to. So I've plugged the Cetus into my computer through USB, and I've turned it on using the switch by the power cord. And if you go to Cetus's website, cetus3d.com, and go to software, you're going to grab Up Studio. I've already installed Up Studio. We've got it here. The first thing you have to do is create an account. So you hit sign up and go through that process. I've already done that. So I'm going to log in with my account. And you need to activate your serial number. So it will detect your printer and then you just activate it. I can unbind it from my account as well. If we're going to print, you can choose your printer from the list here if you have multiples. They're kind of done by serial number. So make sure we've got that printer selected. And then we'll go to up. So this is kind of your slicing environment. You can press plus and you can add a 3D model from STL or a 2D picture, or some kind of primitive shapes. So here is this guy. It's obviously going to be a little bit flat on the bottom, but that's fine. And there's quite a steep overhang there. And you can actually see a visualization of those 4 screws. So you want to avoid them as much as possible. We have some options over here. We can kind of view it in X-ray form, kind of thing. View it back as a solid. We can rotate them around the different axes. We can translate it or move it. Kind of all the standard tools you would expect to have are available over there. And then if you're going to print, we've got some print options. So you've got quality, which is fine, normal, and fast. It's not clear to me up front what exactly quality means, whether it's slower because it's not related to the layer thickness, which is a separate metric here. Then you kind of choose your different infill from some presets. I think this is probably more than enough, 20%. And you can choose like where the infill shows up. So you can just say no infill, you can say no infill top or bottom. There's 13%, 15%, and then 20. So we'll leave it at 20. I'll leave it at fine. I've already calibrated the Z offset, but this is kind of how high the Z is, 182.6 millimeters. We're not going to use a raft, and we're not going to use support. Before we can actually print, I mean, you can preview it, of course. Before we print, though, you need to initialize the printer because it doesn't know where the head is right now. So you can hear that beeping, and it will actually home all the axes. So it'll move all the way to the top, which is homing the Z. 0 is actually at the very top, really, and it'll home the X and the Y, the build plate. Once it's done initializing, as they call it, then we can actually send it to the printer to print. It even gives you a warning up here that the printer is not initialized. You have different material profiles as well. So we're just using the Tiertime PLA, so we're using the profile for that. If you were using a different material, you may want to configure a separate profile for those settings. And then you would just hit print. And you can see the hot end heating up, and here's the hot end, right here, sorry, heating up. And it sends the entire print file over the printer as like a cache, so it's not streaming it layer by layer from your laptop. There we go. So there's the hot end heating up 34 degrees and climbing. And in a couple hours, we'll have this shape printed to inspect. So I kind of mentioned calibrating the Z offset and such. So that's actually done in the calibrate. But if we look at maintenance here, we can actually extrude material, withdraw, we can stop the motion on the extruder. We have a coated build plate, as we kind of mentioned. The nozzle diameter stock is 0.4, though it does come with other diameters. Not sure off the top of my head what heat 15 minutes does, whether it turns it off after 15 minutes. Yeah, heat it up for that period of time. The material, as I mentioned, was Tiertime's PLA. There's a couple other options here, and as I also said, you can customize your own material profiles. It has been keeping track of how much material I've used. So we started with a 700 gram roll, and now we have 629 grams left because we've done 70 grams worth of printing. That's not just this one item, we've done various prints at this point. If we look at calibrate, so this is where we can set kind of a manual mesh bed leveling, if you think about it that way. So you can set what the delta is at these different points on the bed. So our overall Z is 182.6, but we can have a different offset at 0.1 here. It needs to be 0.6 more, 0.3, 0.1, etc. Since we can't manually level the bed, we have to do it synthetically, if you will, through software like this. So at the top here, we see that serial number, and we are connected through USB, but we have the ability to do this through network, and we can print without cables. So under printer, this little icon down here brings up some settings, and you can choose the SSID for your Wi-Fi. Obviously, we'll just choose one at random. Put in your password and hit confirm. It will actually connect the Cetus to your Wi-Fi, and at that point, you can just unplug the USB cable, and every time the Cetus is turned on, it will automatically reconnect, and the software will find printers on your local network if you're connected to the same Wi-Fi SSID. And then instead of saying USB, it'll show that it's actually network connected, which is kind of a fun way of printing if you haven't experienced that before. All right, so here we are with the resulting prints. Like I said before, it's a very different experience than we might be used to. One of the things that's interesting is how the slicer actually accounts for the screws in the middle of the bed and shows you them in the visualization of the bed in the slicer. I, of course, paid no mind to that. And so some of the bottoms of my parts have the shape of the recessed areas for the screws in them, so they're not perfectly flat. I also ended up making a bit of a mess of the bed. I was concerned with it not being a heated bed about the adhesion that we may or may not have with the filament, and that was not a problem at all. It was actually the inverse. I had to hack away at it with a scraper just to get the thing loose. It's a lot easier when it was a raft. So the first cube that I printed here was 20% infill, or the lowest preset amount of infill that they had there. And that's 0.2 millimeter layers, and I have no complaints. I forgot to turn off the support generation. So there were supports, though we know that this doesn't need any. So I just peeled away the supports, and of course on the bottom we have that typical surface you're left with when it's printed on top of a raft, where you can see the individual lines a little bit. But the top is pretty good. There's a good amount of connection with the outer walls, minor gapping there, so maybe there could be a little bit more overlap, but I didn't really go too much into the slicer to figure out what options I had available in that regard. The other cube that I printed it completely hollow, and I really just wanted to see how it would turn out. But I also printed this one using the fine preset. It's still 0.2 millimeter layers. I think it prints slower, I'm not entirely sure. But definitely the surface quality of this one on the walls is better than the first print that I did. And obviously we weren't using any supports at all this time, which we didn't need. I didn't print it on a raft. So this one also has the marks from the holes in the middle of the bed. And I had to chisel it away from the bed surface. Since I did no infill, we're bridging the entire top, including the inset Z there. As a result, it didn't really connect to the walls well at all. But I'm not faulting the printer for that. That's completely user error. Then I did an overhang test. This again, no raft, so it's got the holes. And it did pretty well. I would say that on the bottom here, it's acceptable up to probably 60 degrees. If you weren't super concerned with the surface, you could do 65. So the cooling shroud there, much to my surprise, works a lot better than I expected. The fan here serves two purposes. So it's blowing past the cold side of the nozzle, that unique kind of heat sinky-ish design on the top portion of the nozzle. But this shroud here redirects some of that airflow into a circular fan shroud right at the nozzle tip. And it seems to perform pretty well. I'm not a huge fan of these kind of 2-in-1 fan designs. I much prefer to have control over a separate fan for part cooling versus the hot end cooling fan. But in this case, that's what we have, and it works. Then I used that neat option in the slicer there to just grab a primitive shape and plop it on the bed. And so that's what we're left with here. It turned out well. It was printed on a raft, and so I peeled away the raft, so we do have some rough surface here. And because of the steep overhangs, some of the lines here didn't really attach, so they were just stringing and left hanging, so I ripped those off. But other than that, it turned out quite well. Took maybe 3 hours or something to print this, so it was printing rather slowly. And it's supposed to have this kind of faceted design. It's a kind of rough geometric shape. And that's all with the stock PLA that they included. I didn't want to have to get into the business of, tuning this for a specific plastic, or making sure that I was printing at the appropriate temperature for a different plastic. I figured I would just use their pre-configured PLA. Since it's available in the slicer, you just choose that and go. So where does this printer fit in? I mean, why would someone buy this over maybe an Ender 3 or something? I think the biggest benefit, aside from the fact that it's built with very quality components, is the Wi-Fi and the way that it integrates with the slicing software. So their whole closed ecosystem works very well with their parts, or their printers. And you can have multiple printers. So you can just pull it from the drop-down list at the top and select, say, one of 10 printers in the front of a classroom or something. So I think that would be useful, where you have students in a class at various stations and they can just pick a printer and send a print job to that printer. It may be a great educational tool in that regard. It's quiet. It's not 2208 or 2209 level quiet, but it's not, it doesn't play music like you might hear in the background from another machine that's printing. It does make kind of a tick-tick-tick noise from the motors, but it's not disruptive by any means. The fans in it are quiet, and you know, they've obviously chosen good quality components. I mentioned that a second ago. So these are Moon's steppers, which are supposed to be very high quality steppers. They have Gates belts, which we've seen on some other machines. And of course, we're using linear rails on X, Y, and Z. They're not Highwind. I'm not exactly sure the brand. I'm sure I could look it up. But there's no slop or play in the carriages as they roll up and down them. And we don't have to worry about tensioning the wheels or the wheels wearing out over time and replacing them. So from a maintenance and serviceability standpoint, these should pretty much be good to go. Nothing for you to worry about there. I think it's neat. I'm not a huge fan of the spool holder, but that's really a minor gripe. But it was something different and a unique experience. So hopefully you found that useful. Remember to like and subscribe and leave a comment down below. Let me know if you have any questions or if you'd like to see something else specific on the channel. Thanks for watching.